Are you guys able to hear me?
Hey, hello.
Hi.
Yeah. So as said last day, today we are here to look at if you guys facing any installation issues or if you have any questions before we formally start the class tomorrow. So I hope everything get installed, or do you guys have any issues? Anyone can share the screen and show me if they're facing any issues regarding Python installation, Docker, or any other tools out there that we have discussed last day. Snehita, Prashant, Nikita.
Yeah, I am
Actually,
actually. Yeah, you can go ahead.
I have installed Docker, Jupyter, and Python and Visual Studio also, but I just need to create an AWS account.
Okay,
Mm,
okay, yeah, that's great.
Yeah,
And I hope you are. Did you get a time to look at the basics of the Python?
yeah. I'm just in like looking at them. I mean, I'm going through that Python in W3 schools.
Okay, Nikita.
I am actually facing issue with this Jupyter.
Yeah, you can share your
Yes.
screen and show it to me.
Yeah.
Let me make it a present. Okay.
When I actually go to command prompt and do this, can you see my screen?
Yeah, I can see just the browser.
Okay. Just a second. I'm sorry. I'm unable to share the entire screen.
What you need to do, you just click on the share screen, and then you will see there is an option called entire screen. Option will come.
Yeah, that is what I'm doing. Let me just retry it. Yeah. So when I did this, I'm getting this. When I go to like command prompt and execute all the commands, what did you see?
Yeah, so it seems things are already installed. You just need to write Jupyter Notebook here.
Yeah, but it shows it's not recognized.
Can you just write notebook?
Okay.
Hmm. Okay. I think Jupyter is. Can you run that previous command pip install Jupyter Notebook?
Are you asking me to run this pip install notebook?
Yeah. Okay, it's again the same.
Yeah.
Okay, now can you type Jupyter Notebook? Again the same issue.
Yeah.
Okay, just give me a second. Can you type pip show notebook? Can you type pip show notebook?
No, I just did
Okay, what's coming? Like, can you go to the top? Yeah.
it. Sure.
Okay, it's coming, right?
Yeah.
If this is coming. Okay, type Python hyphen M notebook
Hyphen N notebook.
hyphen Python space hyphen
M
M
N.
space notebook. It should be
M. Okay.
M. Okay, open using Google Chrome. Okay, now it's working. If something is there, like it's not getting loaded.
Uh, yeah.
Yeah, yeah.
It's okay.
Same way, you just check whether you have this in
Uh,
the Visual Studio Code or also not.
yeah, I got the Visual Studio thing. Like,
In the Visual Studio Code, notebook is coming.
uh, just a second.
Just click on the new. Go to the file, new file, Jupyter Notebook.
Jupyter notebook. Yeah.
Click on that. Now just type 2 plus 2 or something like that.
Yeah.
Run it. Run the cell. Not generate. Run. Okay. You need to first. There's a pop-up coming in the bottom. Click on
Yeah.
install there. And Docker is also got installed, right?
I think this
Okay,
is
I
good
guess
to go, I guess.
it's
Yeah.
done. Yeah. Again, go to the untitled one Python. Again, run it. Go to the browse marketplace for kernel extension. Click on Jupyter. Yeah. Click on install.
Yeah.
Yeah. Now again, go back to the notebook. Run it. Python environment. Select Python 1.13, 3.13. Install. I'll request you if you have 3.11 still in your system to uninstall it. Otherwise, the two versions of Python will create some issues.
Okay.
You can check the control panel if you have the two versions, 3.11 and 3.13. So keep 3.13. Can you open your control panel once? Go to programs, uninstall the programs. Here, go to the Python. Yeah, if you see here Python 3.11 and 3.13. So uninstall 3.11. Click on the uninstall. Okay, let me go back to the Visual Studio Code. What will happen in the background? Oh, it's still not running. You can cancel that Ask Pilot window. You can it will keep on happening. Click on restart there.
Here.
Restart, yeah.
Restart.
Generate code, yeah. Restart, yeah. That one. Have you clicked on the restart?
Yeah, I did.
Yeah. Now it's running.
Yeah.
Fine. It's been set up. There's no issue.
Thank you.
Okay. Prashant, Snehita, do you guys have any questions or facing any issues?
No.
Snehita?
No.
Okay. Any other questions you guys have? Any other question related to codes or any other questions? How you're going to proceed regarding classes? Okay. F- Fine. So I'll just tell you how we are going to proceed. So First, we will cover the basics. In the basics, the things that we're going to cover is Python. First, we will be starting with the Python. Then we will cover the pandas. After covering the pandas, we will go with covering the SQL, PySpark, MongoDB. Then we'll be covering data warehousing, then data modeling. Data warehousing and data modeling, all these concepts will be get used to build your effective pipeline. And also in the how do you guys gonna build a data warehouse. When you heard like data warehouse, I'll just show you a couple of examples. So data warehouse is not a standalone thing. It's a architecture where you have this kind of design we create. So there from the source data, you need to create a staging area. The staging area where your ETL pipeline will get deployed. That will pull the data from operational system, external system, or the flat files. So here your ingestion tool will be get used. You will be transforming your data and loading the data to this warehouses. In the warehouses, you will be creating a metadata tables, summary data, raw data, and from this data warehouse, then again the data will be further distributed among the data marts. A data marts is basically the specialized data. Data warehouse is where all the data comes, like accounting, HR, training, web clicks, you just name it. All the data of an organization will come to the data warehouse. To even improve the further your query efficiency, we divided it into data marts. Like accounts data will be one separate database, HR data, and from these data marts, all your tools will be get connected, like your BI tools, Power BI, Excel, Tableau, your data analysis tool, your data mining tools, your machine learning tools, reporting tools. Everything will work on the data marts. Okay. So this is the flow that data engineers work upon from staging area till the data marts. And that you are building, and that everyone building, it does not matter which tool you're using, whether it's being a Snowflake, Informatica, AWS, Azure, GCP. These three things you will be working on. And in order to do this, you need two, three skill sets: writing Python code, writing Spark code, and writing SQL queries. I'm again emphasizing on writing SQL queries because it's important. It's important to fetch data from operational system using queries. Also, it's important to define the data warehouse, put the data in data warehouse, in data marts, everywhere your SQL queries get involved. Got it? If you just search for like top three ETL tool, so you will see Azure Data Factory, AWS Glue, Informatica, Talent, Oracle Data Igniter, Stitch. So these all are ETL tools, and it's not possible to learn all of them. So what we'll do, we'll learn fundamentals. We'll learn the fundamentals. So whatever tools your organization is working on, you can easily adapt to it. More or less, they're following these things. Where we have that image. From ETL, you go to data warehouse from the data mart. From data mart, the OLAP servers are there, and that every reporting happen on top of this OLAP server. Okay. If you look at that example of ETL, I've just told you these are the ETL tools. If you look at, then you have a different data warehouse tools also. So these are data warehouse tools: BigQuery, Redshift, Snowflake, Azure, Teradata, Azure Synapse Analytics, IBM DB2, Oracle Autonomous Warehouse. So these all are data warehousing tools. So we talked about the ETL tool, data warehousing tools. Data Mart will be a part of a data warehousing tools. So you will keep on hearing these names like Redshift, Snowflake, Azure. So don't get overwhelmed by it. All perform this similar work. These are different vendors. It's from the AWS, it's from the Azure, it's from the Snowflake, it's from the Teradata, Postgres, Oracle, again Azure. You have Amazon DynamoDB, Cloudera, SAP HANA, SaaS data is there. You click on this, you will get a top 15 where we have Amazon Redshift, Microsoft Azure, Google BigQuery, Snowflake, Micro Focus Vertica. For NoSQL data warehousing, you have Amazon DynamoDB, PostSQL. So these all are tools we have. Okay, and these will do the kind of same thing as you have seen here. That you will be doing ETL pipeline, your metadata repository, monitoring and integration, data warehouse, data marts, OLAP server, and all the reporting will happen in here. So remember this architecture. Okay. I'm just talking about the overview, like what you guys can expect from this data engineering world, and what are the different terminology you keep on hearing. Like if you heard like Kafka, like what is Kafka out there? Can anyone say what's the use of Kafka? Why we use Kafka? Anyone? Snehita, Prashant, Nikita. Why Kafka? Can you guys just Google Kafka? Messaging. It's a real-time streaming platform that using messaging system to fetch the data in real time and show it to the dashboard. So if you just Google like, okay, what are the real top three real-time analysis tool. So there you get a names like Apache Kafka, Amazon Kinesis, Apache Flink. These all are, so we will be covering the Apache Kafka in detail because it's an open source. Amazon Kinesis, it's same like the Apache Kafka, and Flink, Apache Flink is also an open source that you add at the output of the Apache Kafka to do the real-time analysis. As the data is coming, you will do the analysis. It's not like that. It will not follow this system. In order to do the analysis, it first need to go to warehouse data mart, then OLAP server, you get analysis. But in the real time, it's become slow. So what we do in the uh, Apache Flink, Apache Flink works like that. So here the application device, etc. streams are coming through Kafka, and you will write a query on top of it directly on the streaming data, and that will get powered through application database in the stream data. Okay. Now, a question like which big data services used at each stage? Big data services used at each stage is primarily as a data engineer is going to be the Spark. Spark and Hadoop as a storage, which is which is not relevant anymore. Hadoop, but still some company uses it. So we will be talking about Hadoop ecosystem because this is the beginning of a big data. So you may know, you may not be knowing about all this. Some companies still using it. There used to be Uzi, H-Catalog, Pig, Hive, Mahout, Avro, HBase, Scoop, Flume, Zookeeper, then MapReduce, Yarn, and HDFS. Still using a lot of things from here. Like we're still gonna use the Hive, we're still gonna use the Avro file format, we still use the HBase storage, Zookeeper for coordination. So this used to be the beginning of the big data world, the Hadoop ecosystem. But slowly, all the individual components you're seeing here is being replaced by the Spark ecosystem. Is being replaced by the Spark ecosystem. Here. So Spark is the one that you will be using regularly to process your data, and it support R language, SQL language, Python, Scala, and Java. You can directly talk with Spark using SQL queries or using Python code. The Spark is written in Scala, so you can talk with Scala language also, Java also, and R also. It can perform the Spark SQL, Spark streaming job. So earlier, in order to perform streaming job, it's very difficult to do the streaming with the Hadoop ecosystem. We'll talk about it in detail when we'll study this, start with the big data engineering world. So as I told you, Spark streaming like Kafka, then you can perform machine learning also with the Spark. You can perform graph processing with the Spark.
you can use R language on the Spark. So while covering this, we'll be talking about the all these Kafka. We'll talk about the Apache, the distributed system, the nodes, and how we monetize the resource you have. What is the cluster? What is the nodes? What should be the RAM for efficient partitioning? All that thing we're gonna study when we'll cover the Apache Spark. And in the today's data engineering skill set, Apache Spark is the must to have it. You should be knowing the Apache Spark. Even the new architecture which is coming, the PySpark, the Medallion architecture. So this is a Medallion architecture where everything will be part of a same flow. There won't be a different data sets out there. So it's a new architecture that's been followed. It's called Medallion architecture, and it's a bit different from this. This is the still 90% of the company use the same. The older data warehousing architecture, but this is the evolving architecture, whether it's been a batch data or a streaming data, all everything will come as a raw data in a bronze layer, which is a raw ingression, and the same will go to the silver layer and the gold layer and directly applied by BI. So there won't be any data mart out there or data warehouse there. It will be a part of a single flow. It's more simplified data pipeline. So still, it's in adoption, not adopted to the fully. Still, hardly 5 to 10% the companies are using this architecture. But yeah, Delta Lake slowly, it's getting relevance. So we'll be focused on this pipeline also through the Databricks. Now, question for you guys. So I've told you like what you're gonna study, what we have in data engineering. So Prashant, what you have understand by all this till now? How you see the data engineering, like what they're gonna do, or what you're gonna do?
So we create a data pipeline and we work with that data with using these tools.
Okay. Anything else? Nikita?
Processing the data too.
Okay, processing the data. Snehita? Yash? Okay. So as a data engineer, yes, Nita, go ahead.
See, just building the pipelines
Mhm.
for getting more clean data.
Okay. So building a pipeline is one part of the data engineering. I'll say around 50 to 60% of it. But there's a more to it. You need to also know about the tool selection for the pipeline. What tool you're going to use? Where do you need a Spark? When to use the Spark? When to use the Kafka? When to use the normal pandas file? What is the while for the data ingestion? What tool you're going to use? Is the data ingestion required uh, web scraping, or it's a direct SQL connection, or it's through API you're going to bring the data? So in that terms, you should start thinking upon like, okay, I need to move the data from one place to the another place. The starting point is like how to bring that data to my platform. and what should be my platform, and your platform depend upon the size of the data and what is the frequency of the data which is coming. I have talked about the three V's, right? Whether your data is in terabyte or petabyte or a megabyte or just a Excel file. What is the frequency? Is it coming daily basis, weekly basis, hourly basis, or every minute the data is coming? So based on that, you will choose your data ingestion tool. What is the variety? Is it just a SQL tabular data, or it's include the audio video files also? So based on the nature of the file or the data and the frequency, the rest of the pipeline will get defined. What kind of storage you're gonna have, what kind of processing tool you're gonna have, what will be the output. Okay. Let's talk about a scenario where there's a toll booth. Okay. And the company want to build a real-time dashboard that will show the number of vehicle passing by through that toll gate. So we want to create a dashboard. So for that, how you're going to build a pipeline as a data engineer? Think about it. How you going to ingest the data? So I'll just repeat again. Let's say there is a toll booth and you need to create a real-time dashboard to count number of vehicle passing by. So as a data engineer, how you will build a pipeline and what are the components it will go? What will be the storage? Which application you will use for ingestion, for storage, for processing? Like it will be a real-time processing, will it be a batch processing? What are the components of the pipeline going to be? So first we will connect with the edge devices. That is the sensor data or the camera data which is placed on the toll booth, correct? Let's talk about just the sensor data. That there is an sensor whenever the vehicle will pass, it will blip and it will mark as a count. So in order to connect with sensor data, you need to list that all the sensors, which is basically an IoT devices, to your cloud, registered it to the cloud, and from there you will list it down. And from there you will use the Kafka to ingest the real-time data because continuously the vehicles are coming, and once the Kafka is streaming in the real time, you will use the Flink or the Spark to do the processing. See, most of the time you will be doing batch processing, but in the real time there is a whole different tech stack. There you will be processing the real time data. So after processing, you will store that into the Redis or real-time data storage, and then show it to the dashboard either in the Streamlit or Grafana. So this is how you can easily see what are the number of vehicle passing by from that toll booth in a real time. So in that manner, you need to start thinking, okay, how can we ingest data? After ingesting data, how we are going to process it, how we are going to store it, and how we are going to so that other team can use it for the visualization. Okay. Any other questions you guys have? Okay, thanks everyone. We'll continue from tomorrow, and tomorrow we will start our class with Python sessions. If you guys have any question, let me know. We will wrap up the class for today.